welcome to our next installment of our current OS webinar series for North American market. Today we have a really exciting panel. We'll get to introductions of our guests here shortly and frame that up. But I just got to make my comment that when we had our planning call, it was a great discussion and really made me look forward to this session. So today, we're going to talk about how to future-proof power systems for expanding DC loads and sources. And sort of the context behind this is, we talk so much within current OS about direct current, but really we find when we apply direct current that the built environment is a hybrid environment, and we have direct current and alternating current. We have new technologies, we got older technologies, and not everything is as clean as a perfectly executed DC infrastructure. So that's sort of the frame of what we'll be talking about today. And so we'll give you a couple other comments. So from a housekeeping perspective, we're using a new tool for the webinar today. Just go ahead and put your questions in the chat if you have any questions. And when we get to the Q&A portion, we'll go through those chat. Hopefully we'll get through and be able to get through all questions from the audience. I think that'll be great. We'll be recording the session as always. We'll send out via email a link to the session if you want to watch it again or share it with a colleague. And then of course we have our current OS YouTube channel, which you can follow or see any of these sessions as well in that channel. So multiple veins, really just talk a little bit about our world from a current OS perspective. We're electrifying, and there isn't an easy button so much to speak of for direct current systems. So we're trying to work through all of that and create that easy button for y'all and to understand how that future built environment might look. Also, a little bit about the current OS organization. We're open, global, and independent. As you can see from all of the logos that appear on the screen today, we have quite a variety of manufacturers, both in the source space and also in the load space, and in that in-between space where sources can become loads and loads can become sources. So one of the value propositions of direct current. We always like to include our project slide, and that this isn't just a theoretical lab experiment, but our current OS partners are deploying real DC DER connected systems, including microgrids globally, with projects in North America and projects in Europe. And if you want to know anything more about some of the projects we're doing, I would direct you towards the current OS webpage. And you can find more information there and sort by application type. So we really wanted to talk about the frame for today. So really when we think about direct current systems, it's a high engagement of distributed energy resources. And there's really four value propositions that come along, which is, of course, the energy efficiency, being able to get more power than you can get from the grid, being able to have seamless transitions. In the AC microgrid world, you got to make a decision early on about open or closed transition, and that really drives complexity and costs. And then finally about power efficiency, which are problems that go away when you adopt the current OS way of thinking about DC coupled systems. So as we go into our session today, I'm going to hand that over to my frequent collaborator, Brian Nelson. And Brian, if you could go ahead and talk a little bit about yourself and what ABB is doing, that would be awesome.
Thank you, Daniel. Yeah, thanks for the opportunity to be here today. I do apologize to the audience. I'm a little under the weather. So hopefully the opportunity to talk about what current OS is doing, just DC in general, is an exciting one. So I look forward to the conversation today. My name is Brian Nelson. I'm the Renewables leader for ABB's Electrification Business Unit. You can see here on the screen, ABB's a part of a very large company. Of course, not only do we do electrification, but motion, process automation, robotics, and discrete automation. Myself, I have been with the company for 16 years. They've taken me all over the United States and globally, and I've really found my passion here as the renewables leader, where I'm talking with kind of the entire range of users and producers of renewable energy, and it really dovetails just so well into the conversation that we're going to have today. I'll leave you with one fun fact about myself. My household has 9 pets, and it actually was 10. So if there's anybody else out there that's as crazy as I am and have that many pets, let's compare stories. Thank you, Daniel, for that. And I will advance the slide here and throw it to Cedric.
Thank you very much. I'm really glad to join this panel and be part of this conversation. So a little bit about Shoals. Shoals is a leader in the 𝗽𝗲𝗀𝗀𝗀 system, so electrical balance of systems. We have been producing this type of equipment, especially for utility scale solar, for almost 25 years. All our operations are in the US. We're in Tennessee, north of Nashville. In 2021, Shoals was listed on the NASDAQ, so we're a public company. And a little bit more about myself. I joined Shoals almost a year ago as the senior product manager for new markets. And by new market, we are talking about everything that is basically getting away from electrical balance of system for solar systems, so mainly BESS and data centers. So quite a lot of applications that are leveraging DC or that will be leveraging DC. I have over 15 years of experience in the as a product manager in the lighting industry, especially driving innovation in, I would say, context where the landscape is changing and changing very fast. I was really at the forefront of LED lighting when it became a thing long time ago, and that was an exciting time. It became a bit less exciting afterwards, but very excited about what is happening in the landscape right now. So very quickly, I'm going to move the next slide. A practical application of DC application. One of the products we launched is a DC recombiner for battery storage, which allows us to combine multiple inputs on the solar side and on the battery side, and push everything to a single inverter, which significantly simplifies things. I'm showing that because that's going to help us a little bit later. And I'm going to pass the baton to Casey.
Hey, good afternoon, everybody. Thanks for joining us today. My name is 𝗽ห์𝗲𝗀𝗀𝗀𝗀, I'm an application engineer for ReBoSS, representing 𝗽ґ Solution. We manufacture balance of system products, switchboards, and integrated assemblies, primarily for the interconnection of renewable energy resources and battery energy storage, either for local consumption or as input to the utility grid. As of late, in the last 18 months or so, I guess our background in renewable energy and storage has becoming increasingly relevant to data center construction. So we've been expanding our portfolio into distributed energy resource applications and critical power distribution for IT loads in data centers. We manufacture all of our products in the United States and North Carolina. I've been in this industry basically my whole career, for the last 20 years, dealing with electrical distribution equipment, and it's amazing how far things that have come both on the renewable side and the data center side. You know, our biggest customers 15 years ago were all the oil and gas companies and the fossil generation plants, and it's amazing and exciting how fast everything has changed. So happy to be here today and looking forward to the conversation.
Awesome. Thank you, Casey, and Cedric and Brian. I really, there's a couple things in your introductions that really sort of themes that stood out for me, and I got some questions organized that I'd like to throw at you guys, because I think what this panel brings to the table that's very unique, and I think our attendants will find interesting is, right, it's just not this speculative slideware, right? It's not some startup getting, no shade at startups, but it's not just something that only exists on a PowerPoint slide, right? You guys are actively engaged in real world projects. And maybe if I could direct the first question at Brian, can you share a real world development or deployment that highlights the tangible benefits of DC architecture? And that could be, focused on the balance of system like we're talking about, or other values like improving reliability or flexibility within system design. Like, feel free to take it where you want, but can you talk a little bit about that for me, Brian?
Yeah, I'd love to. And so, I think what I'll do is just take it back to the kind of the beginning of when ABB really started to realize the opportunity around DC systems. And for ABB, if you're not aware, that really started in the marine business. ABB has a pretty robust marine business, and where we found kind of the first low-hanging fruit as far as how ABB could leverage technologies that either we have direct control of or partnership with, was in that marine space. So actually in 2013, way back when, the kind of first low voltage DC systems started to become realistic for marine vessels. And so we're talking about 1,000 volts DC at the time, up to 20 megawatts in size. And the kind of the benefits that we kind of know and love, I think, in this community started to prove out, right? So we started to see energy savings of 20 to 40%, a reduction in operation and maintenance costs of up to 30%. And, all of that leads, or I guess stems from things like the improved conductor utilization, and just a tremendous amount of other benefits. The marine space is quite interesting because, right, it's contained, and it's not this massive grid. And so in a way, it was a really fascinating space to start to see this adoption kind of kick off. And that has led to, I think, the further proliferation of these DC systems and thinking kind of outside of the box. Because the other thing that moving to DC from a marine perspective kind of unlocked for us was now this kind of easy integration of energy storage, and how can we think about other ways to pull in more electricity into the system now that the integration has become a lot easier. So things like shaft generators, as an example, as a means to improve the efficiencies of these marine vessels. And so that's really where ABB started to cut our teeth in kind of a system that we had a kind of robust knowledge and appreciation for. And from there, the opportunities, just started to grow and grow and grow. I'll take you back, just one more thought on it, Daniel, and then I'll let the other people talk too. I will never forget the first time I really saw personally what a DC system could look like. I was responsible for Duke Energy way back when for ABB. Duke Energy has this amazing technology center in Charlotte, North Carolina. And we would get to go, and it was a test bed for some products, and it was just a great future look at what these large utilities were thinking about and considering as the grid has gone through and continues to go through these dramatic changes. And we're going through the tour, and a friend of mine, David Lawrence, who was with Duke at the time, he said, "Well, come on over here." And if you know David, he's a really passionate guy. He said, "Come and look at our DC room." I said, "DC room? what are you talking about, DC room? And that's when I first started to think, holy cow, this is more than just marine. This is more than maybe just some means of using a DC bus. We are thinking about really the future of what DC can look like. And this was years ago, mind you. And so that's really when my fascination with DC started. And as I've become more and more familiar with it, it's just been a tremendous opportunity to push the industry in a forward position. So started with marine, but now the applications abound.
Yeah. So Cédric, I know you have at Shoals, you must see a lot. I mean, everybody I think understands your market presence. Like, any thoughts on that same question?
Absolutely. I can actually add a little bit to what Brian mentioned. So because we are obviously very involved in utility scale projects, and we keep having conversation, whether it's with utility project, but also behind meter with a data center project, with customers who want to simplify their architecture. You look at solar sources and battery storage sources; those are DC sources. A lot of the systems in battery storage are AC coupled, so basically they are fully enclosed with their own inverter. One of the conversations that is starting to worry some developers is basically making those systems more simple and avoid the multiplication of all the components. So, for example, let's say you have 20 battery units on a project, each of them containing their inverter. That means that you have 20 inverters, and that's a concern for efficiency and complication for some customers. So we had conversation asking us, can you do something about it? And that's actually the nature of what we are doing. We have a system that allows you to basically take a DC input, recombine it into one enclosure, and push it into a single, either an inverter or DC to DC converter, depending on the type of project. So we are starting to have some good successes in projects that way, and maximizing efficiency of the overall systems, and basically having a very clean architecture that allows you to control very well the different components. So this centralization of the power conversion is really helping here. And you can also add that and combine that with solar. So it makes the whole system much more simple and more efficient, I would say.
Awesome. Thank you, Cédric. I think that, again, the title and what we are looking at in this presentation, right? How to future proof your system. We all sort of recognize the need or the benefit of bringing on these DC nodes, but the real world is more complicated, right? We're going to have sort of this hybrid environment of mixed AC nodes and DC nodes, and really, I want to throw this out at Casey. When you approach the problem set of what to push towards DC or what to approach to keep in the AC domain, what are the typical technical or regulatory challenges that you encounter in your deployment, and how do you sort of negotiate that decision making sort of process on how to overcome some of those technical and regulatory challenges?
Yeah, I think you hit it on the head in your intro, Daniel. The absence of an easy button when we talk about a DC distribution. I mean, obviously we have a wealth of equipment intended for various applications on the AC side, and DC applications tend to be very application specific and very limited to certain application use cases. So when I'm researching a DC application, I've got to call Brian or maybe find his the ABB Marine website and see how they're managing the distribution in a marine application, or see what Cédric what they're doing on the utility scale PV side. And so that's where I think that's where we are. I mean, in certain application and use cases, the technology is very understood, but I think in general, manufacturers, OEMs, and end users are looking for guidance and answers. In particular, when we talk about the data center use case for DC distribution, and we talk about a grid to chip DC voltage, just as an example, I mean, power electronics operating in the 15 to 35 kV range, they're not widely available, and they're not widely defined by product standards. So that has a lot of people concerned. So just in general, new codes and standards for installation practices, equipment standards, those are the biggest challenges, and then once you identify equipment that may work for the application, then there's another hurdle in front of you to determine how to apply and to correctly apply those pieces of equipment and educate the installers and the end users on what you're doing. So it's there's a lot in front of us, but the benefits are definitely there.
Awesome.
I can just
go ahead.
Sorry, Daniel. I was just going to say, it's I think through those conversations where I have personally found the extreme value, because for somebody like ABB, of course, we have solutions, but we also are working with Epic Solutions, ReBoSS, and Shoals to help them serve their needs. And it's that kind of collaboration in those standards, and what is the application, and then you kind of can go through the laundry list of other considerations, because as a component supplier, you really need to dig into the nitty-gritty to make sure that you have a safe and valid device that's going to perform throughout the lifespan of that particular project. And only through collaboration, I think, like what we're doing here, is how we kind of continue to move not new technology, but to move the conversation forward, which ultimately will increase adoption.
Yeah, I would just add that for us, it's not as much finding the components. I mean, we can find them with partners like ABB or some others. It's sometimes that the components that exist are not always listed by, or registered components by UL. So we have to be a little bit more creative about that. Some of those components are certified for other standards, but very often we have to basically get on-site certification by a third party because of that problem. So, and I'm anticipating that we're going to see, as we move towards very high power application in the DC on the DC market, we're going to have a little bit more of those issues that we're going to have to resolve altogether. So we're going to have to make sure that the certification bodies are up to speed with some of those tests, and have the test in place for those applications.
And that's that's a great segue, Cédric. We talk a lot about standards, and I know I've been collaborating a lot with my ABB colleagues on the UL 3001D, and of course we've mentioned Underwriters Laboratories or UL Solutions and sort of their efforts around direct current, and they are a member of Current OS and on representing the board of directors, and I think that work is central to what we're doing. So I mean, the next question I'd like to throw out there for any of the three of you to ask is, specifically what standards, partnership, policy changes do you believe are most critical in scaling DC-based systems across a wide variety of industry applications? Not all at once.
Yes.
I think more of what we're doing here with. Oh, go ahead, Brian.
Casey, why don't you go ahead first?
Yeah, I think it's more of what Current OS has been doing. Maybe outside of the U.S. in codes and standards adoption push in the IEC markets. I think we need more of that in the U.S., and I think it's starting. You know, collaboration among the various codes and standards organization, like NEMA and UL and IEEE, even with input from IEC to really establish testing, labeling, trainers for contractors, and ultimately AHJs who will be responsible for approving installations. I mean, with the DC distribution, there's an increased risk of arc flash hazards and so on. So how do we manage that? How do we educate that? And it's just, I think it's a collaboration among the manufacturers, the OEMs, the integrators, installers, and the standard bodies.
Awesome. Brian, you want to take that one next? Yeah, Casey hit the nail on the head there. You know, from ABB's perspective, of course, you know, IEC 60947-2 is obviously a standard that we're leveraging today to bring to market, you know, one of the first solid state circuit breakers that is, I think, going to be instrumental in the future of direct current systems and microgrids. As Casey mentioned, there's this, you know, arc flash potential that needs to be managed, and it needs to be managed in a different way. And the speed of solid state technology and how that continues to develop is critical to, I think, that collaboration. And the industry does seem to be headed in that direction, you know, let's all get in the boat and row together, and we'll be able to accomplish things in a much faster way, because the reality is we can't wait and honestly squabble about if this standard or that standard is the preferred. We kind of need to all be going in the right direction, because we are at the precipice of a tremendous gap in you know, generation growth and load growth. And the use of DC and DC systems is this incredible lever that needs to be pulled, I think, as a means of all, you know, kind of everything together to make sure that we can kind of keep up with this technology shift and change. So I think Casey is right. And then it's about how do we think about these new technologies that are going to be required, like solid state circuit breakers.
Cédric, you have any thoughts you want to add to that one?
I just want to echo all of that. The only thing that I would add is that we cannot wait, but also we don't want the standards to become restrictive and limit the creativity, because some of the systems that we are creating, we still don't know exactly where it's going to end, and you don't want to limit the possibility. So you need standards, especially on the certification of components and those kind of things, so that we can move forward and ensure the safety of all of that. But we also don't want to restrict the possibilities. So I think that the collaboration, like both Casey and Brian mentioned, the collaboration between all the actors of the industry are really helping in here, because we all facing common problems. So it's all about finding the priorities and solving them, and keeping moving together on that.
Awesome. I'm gonna go back to you, Cédric, to ask you to start out the next question here. And I think we've heard some mention of some applications, new application types. We've heard people mention direct current data center architecture. We've heard people talk about direct coupled, you know, utility scale systems. And I want to get your thoughts on how do you see DC architectures evolving to support these future applications? Can you maybe expand a little bit on like what you're seeing today and where you think the market will evolve to tomorrow?
Yeah, so I'm happy to take that one. I think that it's just the nature of where things are going. We have incredible challenges in terms of power demand, and with very specific power applications. So in order to bring enough power, you basically need to be very creative and very open about the sources where the power comes from. And we are starting to realize that some of the mix that that allows you to bring enough power start to open the door for power sources that are DC power sources. I mean, I mentioned earlier solar and battery storage. I mean, you are talking in this case of two power sources that that are DC. I mean, if we look further in the future, we're starting to hear more and more about fuel cells. That's also a DC power source. So you basically have a mix of new power sources and also new approaches where bring your own power is, I would say, is part of the equation of some of those big applications such as data center, where the utility may not be supplying all the power that is needed for a data center. So basically, they are starting to look at putting their own microgrid and bringing a portion of the power to make up for the deficit and so on. And some of the solutions are DC power sources. In the meantime, you look at the big drivers in terms of application, and a lot of the applications are actually DC application. You look at data centers. Ultimately you're talking about DC loads. You look at EV charging, especially some of the larger DC fast charging application. You're talking about DC chargers. So it's becoming very logical that you remove the DC to AC conversion in some of those equations. So if you want to scale those type of projects and make them more efficient and find more ways to be nimble for and move fast enough for those projects, removing the conversion makes a lot of sense, because you're effectively connecting DC sources to DC application. So in our opinion, we see a lot of benefits in moving, and I mentioned earlier, simplifying those architecture. So I think that that's going to be working quite a lot in that direction. I see a lot of another point that, in my opinion, is going to be more and more critical is to have solutions that are as modular as possible. That's going to help scaling those solutions for the needs and the future evolution of those needs.
Yeah, I think what Cédric mentioned before about historically, like battery energy storage being an AC coupled application. I think, you know, definitely the move to DC coupling for renewables and battery energy storage, removing that first level of unnecessary power conversion as we're getting into a native DC bus, you know, for data center and for other applications. I think that's going to be the biggest change, you know, with the rate of construction and implementation of both renewables and data center. I think a lot of our specifiers tend to do what they did last time in the interest of speed. And today, you know, it's just all about getting everything to that medium voltage distribution bus, right? That's what everybody's mindset is, whether it's a generator, whether it's solar, whether it's battery energy storage. Okay, first thing we got to do is get to that 15 kV AC bus. So it's just it's a change in thought process and kind of catching our breath to get into the DC coupled mode.
I'll round us out here, and Casey set me up well. But I think when I think about the future and where DC is ultimately going to go, it is actually medium voltage DC. I know that there's obviously a lot of momentum today around data centers. You know, the recent announcement by NVIDIA, of course, to take on an 800 volt DC architecture to power their GPUs. And that's going to be great. And we're going to learn a lot there. But I really think the opportunity to unlock really DC as just a really complete ecosystem resides in the opportunity at medium voltage, and that's at the grid, and having more operations on a grid scale that are medium voltage DC as opposed to low voltage and high voltage, right? The HVDC is there, it's known, it works well. And the low voltage DC and the technologies that are being developed there are moving quite fast. And I think we've talked about all the benefits of what that allows. We're just missing that kind of the icing, right? It's the icing in the Oreo cookie that I think can unlock a really robust grid where we have renewable assets, but also fossil fuel assets, right? And maybe that's the catalyst to hydrogen, and the using electrolyzers to make green hydrogen. And I think once we can get to that medium voltage piece, there is a tremendous opportunity for DC in general. If you haven't read it, there's a tremendous white paper in total transparency. I have not read the entire thing, but IEC just put out a white paper on medium voltage DC and the opportunity there. And one stat that stuck out to me as I was reviewing that was their kind of prediction about the DC power distribution market. And in their estimation, we're looking at $31 billion. $31 billion, not in 2020, not in 2040, not in 2035, in 2030. That's 5 years away. And so that's, I think, where the opportunity is to really advance and kind of unlock DC as this incredible ecosystem that we honestly need to continue to power our future. And so I'm really kind of excited to see how all of that develops. And then maybe we'll see, DC homes sometime. I don't know. Time will tell on that one.
Yeah, totally understand that one. So again, we've gotten to the point in our webinar timeline when we generally open up and address the questions on chat. So I just want to make sure that if anybody listening has any questions, that they remind them to put them in chat, and we'll get to them. But we don't seem to have a lot today, so I wanted to take that opportunity to sort of dive a little deeper into some of the responses that you guys made in that last question. And so I heard a few things that, just to unpack a little bit, we see low voltage DC as a now thing. We see low voltage DC as being something that people are deploying in data centers. They're deploying that in utility scale generation. They're deploying that in commercial scale generation. We're also seeing a trend in the data center space over the last decade of moving from low voltage AC into a medium voltage AC. The comment made about getting to that 15 kV bus, Casey, that was, I think, an astute indicator that leads to Brian's hypothesis and Cédric's hypothesis of more motion, more connection going into that medium voltage space. And I can understand why you guys would see that. So if I could maybe synthesize a little bit of from the comments on, where we see things are today, where we see them going tomorrow, right? Like when we talk about future-proofing the system, where are we expanding on loads? We're expanding on sources. I think maybe a good question, if I could get your thoughts on, is, how do we as an industry, and I've been very excited to collaborate with, traditional competitors in this new market space when we talk about standards creation. But, what are the other things that the industry could do better to accelerate the adoption of direct current technologies? And I don't know, Cédric, I'll just call on you first to start maybe on that.
I think that initiatives like this one, or like the OCP, the Open Compute Project, are great ones to anything that, like, I think, I'm not sure if it was Brian who mentioned this earlier, in terms of standard, it's more the collaboration of the industry. I mean, you just look at the three of us, we are all complementary. All of us are basically, we are not in direct competition, we all a different element in the chain. I think that's the collaboration between all of us to basically develop the application and a very broad spectrum of solutions for a broad spectrum of application is critical. I think that anything that favor that collaboration, and that helps different actors of the industry to work together as solving a problem. But each of us, from our own vantage point, we are one cog in that chain. I can place my product next to Casey's product and use components from Brian. So all of us are basically complementary to each other. I think that it works so much better if we work together in order to try to look at the problem and find solution and look at how we solve the different application, rather than all of us trying to solve the problem alone on our side and compete with each other. In this regard, there is so much complementary that can be had, and the initiative like this one that help us to come together and basically develop what we do best, each of us, rather than I'm always obsessed about these standards, like the VHS versus Betamax type of question, where basically everybody's inventing a solution and then you are competing with your solution. I think that the challenge is so big that we don't have time to wait on that. It works so much better if we basically, for Shoals, we're interested to do what we do best, which is basically the 𝗽H𝗲𝗲𝗀𝗀, the wiring solution, the power cabinet that can basically help connect different elements of the chain. And I think that I can work really well with Casey, and I can work really well with Brian in this. And most importantly, work together to solve as many different problems that are basically related, and offer a very wide array of solutions, not just one small sliver.
Yeah, I'll share a little anecdote. From my perspective, there, it is probably 2008, 2009. I was a young engineer at ABB, and I remember talking to my boss's boss's boss one day, and at the time, I think I mentioned before, our 90% of our business was selling to fossil generation application, to the oil and gas companies, the natural gas processing companies, power generation plants. That was our business, right? And he said to me that in 20 years, the data centers were going to be our biggest customer, and it was going to be all DC distribution. He made those two statements. So he was immediately right about the data center being our biggest customer. By far and away, in my business, is low voltage distribution equipment has grown 5 times over the last 10 years, primarily because of data center. The total market size has grown. And, I think that the DC adoption, the DC distribution adoption in the data center, on paper, he was definitely right about that too, right? But I think that the obstacle was the understanding and availability of equipment to go make it happen. And I think that that's the most important thing that we can all do as a community, because of a lot of reasons. This is so important to everyone, and being able to capitalize on the new technologies in data center requires more power, more direct power, and that's the challenge in front of us.
I think the other thing that I think about is policy. Of course, policy can be a headwind or a tailwind in some cases. And, I think for DC, this is not the United States is going to be the only beneficiary, or Europe's going to be the only beneficiary. This is a global challenge and opportunity that we have. And so then how can we, work together with policymakers in the US or in Europe to help us along here? Because I think one of the missing pieces to this is this, the technology. The technology, while it's advancing at a high pace, it could go faster. And policy could be a beneficial aspect to that, to accelerate that growth. And so I think that's something that the industry is advocating for, but should continue to advocate for with folks like NEMA, what CurrentOS is doing, and others, to make sure that it's understood what the opportunity is, not just from, I apologize, but most of you on the camera here, we're all nerds, right? We just love electricity and we think it's really cool. But we need to get the politicians to also understand the opportunity as well as much as we can to help accelerate that. And so I think that's another opportunity for us is to try to leverage that policy, get more money into R&D, continue to develop the technologies that we need to kind of make this advancement become a reality sooner rather than later.
And I love that thought, Brian, too. We're not trying to, run science experiments because of, some sort of, desire to spend other people's money. These are real problems that we're seeing. We're looking at how direct current can really improve the overall performance of the built environment. And I think that's, at the center of our mission. I'd also like to maybe talk a little bit about, the comments that you guys responded with onto that last questions and like what we're doing within CurrentOS. We're building interoperability standards for a compliance scheme on products so that we understand, like, when you say the word converter, it's very broad, right? So what does that mean? Like different, instances where you have that conversion applied, or even in the installation, right? And like we look at like the installation guidelines that CurrentOS is putting together, and how that collaboration between manufacturers of load equipment and source equipment, and folks like Southwire building, the interconnective tissue, right? Like it really takes this this exchange between our community to be able to unpack all of these issues. And again, this is why I was so excited about the conversation today. Why, we look at things today and it's like, we don't have everything perfectly worked out as an industry, but we're getting incrementally better, and we're inching towards where we would all like to go. And to me, that's an exciting thing to do. And I see, CurrentOS is being this organization, this foundation that is really fostering a lot of that collaboration, and how we get together in a room, and we're able to talk about things at a level that really lifts all boats, right? Like it improves our own like sort of commercial strategies, but it also improves the customer experience, the user in the built environment, what they're able to do and what they're able to unlock. Going back to my first question about, improving reliability and flexibility in the systems, we're seeing more of that. So really, I appreciate those comments that you made. Again, encourage others that are attending the session today to post any questions they may have in chat. We're got probably another 10 minutes here that we can entertain. But I really wanted to talk more about the role of DC in these contexts of AI and grid edge intelligence, autonomous energy systems. When I talk about the values that we're unlocking, I just, curious if you guys have thoughts that really, as we look to keep an eye on how to future-proof systems, like how do you deploy those DC systems with a mind towards ensuring the future compatibility of maybe what comes next down the pipe?
I can go.
Go ahead, Brian.
So to me, it all comes down to make sure that you have the intelligence capable devices to ensure that you can adapt in the future. And I think we are at a place as an industry where intelligent circuit breakers, intelligent switches, contactors, whatever, right? Those are, I think, becoming more and more of the standards today. But that's what's, I think, needed. That's where my mind first goes to that question, Daniel, is make sure that you are setting yourself up for that success. And in my mind, it is about having intelligence as this backbone to potentially enable the future. Because if you are going to leverage things like AI, which is just so, I think, exciting for the industry to kind of strengthen our grid and make it more efficient and reliable, you have to have the data. And so if as a component supplier, make sure you're leaning into that intelligence to help you future-proof your solutions. And maybe you're not using everything that intelligent circuit breaker can do today, but tomorrow, when your customer says, you know, I was thinking that I might want to do this, and then you say, oh, well, hey, I'm already ready. And you don't maybe have to pull breakers out and put new ones in. That would be my recommendation to the audience.
Yeah, and for manufacturers,
I think when you go to a data center conference today, you know, pick one, and a third of the keynote speakers are grid operators. That tells you where the conversation is. You know, that it's okay. How do we get more power? And I think, you know, in the context of DC, and Cedric mentioned it before, it makes more sense. It's more cost effective. It's more efficient to leverage your native DC distributed energy resources and the ability to deliver more power to your IT equipment in the data center space. I mean, that's where we are. And DC enables us to use more power sources, be more efficient, and to deliver more power. So when we talk about AI, like I said, you go to a data center show today, it's about power. Where are we going to get the power? And then also, I think the other interesting aspect of data centers is the conversation about a data center being a grid asset and providing a center mass of energy inertia, I guess, for a lack of a better term, onto a grid, and not being what most people consider as a drain on the grid, but an asset to the grid to provide stability, backup power, and reliability.
And I would say that DC is solving additional problems. I mean, to add to Casey's point, on top of the efficiency and on top of the scalability, it has some additional benefits. You saving on materials. I mean, you're reducing your number of connectors. It's a significant amount of material in massive application like data center that you are saving. The other issue is on space. You look at a modern AI data center and how crammed it is becoming because of the needs for cooling and for all of that. Well, that efficiency and the lack of power conversion results in less cooling. That's one benefit. But even better than that, you are clearing, because you are simplifying the architecture, you are also removing volume. You're basically making systems that are taking less space. You have less conversion units inside the racks. Well, that's more space for your equipment. So in one hand, you have the systems that are becoming extremely crowded, but DC has the potential to simplify and use less material, be more sustainable. So it's all about all the problems that it solves all at once. So it's not using DC for the sake of using DC, but it's everything that it allows you to do in the space.
Oh, great, Cedric.
I love that.
And a great segue. Go ahead, Brian. Flexibility is so important. And DC is just an incredible enabler to flexibility. So I just wanted to reemphasize that. It's critical. Yeah. And I think too that flows well into our first question from the chat from 𝗻𝗻𝗃𝗃, who's asking, how would you explain to a politician or your grandma the main advantages of DC versus AC, or what what's a good like one pager, one liner, or elevator pitch. So maybe let's see, start with Brian on this one, and then maybe go Cédric, Casey.
So I have the humbling experience of attending a middle school career fair in my community on an annual basis. And I try to get the kids excited about renewable energy is the gist, but it's become more and more of a AC and DC. Let's have a conversation around what those things mean. And what I do and what I think proves valuable is to just tell them to think about all of their devices and how many devices have to get plugged into a little box or some sort of inverter, right? And then I say, have you ever felt that inverter? That feels hot. That is waste. And that seems to shine through sort of with the middle schoolers. So I think if you can take that middle school message, I think a politician, should be able to understand that concept as well.
It's gonna be hard to top that. I would say I go back to look at your power sources that you're bringing in the mix and your application. And if you are in an environment where most of your applications are DC application, it makes a lot of sense to reconsider the way that you produce power and the whole chain of power and how you bring power to what you're trying to do. So you look at the data center, it's a lot of DC power. So why would you convert power? Like, I mean, I'll steal that one from Brian about if it produces heat, it basically something is going wrong. I've seen it all my career in lighting with LED lighting. You basically convert power from, you have to go from AC to DC in order to power an LED. You could do things a little bit better. So there is quite a lot of things that you can actually do with DC power for the right application. And I think that it's all about that flexibility when you have problems that are so big and I would say so concentrated, like what you're trying to do in a data center or a large DC charger operation. It makes sense to look at other ways to do things and do it more and do it better.
Yeah, when I was a little kid, my grandparents lived 45 miles from my house. My grandfather called it as the crow flies. We're only 45 miles away, but because of the road system, it took like 3 hours. We had to go south and then north to get to their house. And as a little kid, that was very frustrating. And I think that's maybe a good way to describe what we're doing here, and sort of aligned with the way Brian was talking about with the charging devices. We need DC at the end. At the end of the chain, it's DC. So why not do everything ahead of it in DC? Let's just do it as the crow flies.
Good response here. I think that too, I gravitate to my central favorite theme of the convergence of data and power. And really, when we start talking about DC, it changes the relationship. The AC paradigm is largely hierarchical, where you have this, from the top down. And when we start looking at DC adoption, it allows more peer-to-peer advantage, right? We have this ability to unlock and make better decisions through that peer-to-peer exchange. So, I mean, I don't know if that's Grandma's going to maybe get all of that, but really, when there's also another question on the chat about DC continue. How do we continue to develop effectively without a widely adopted standards? And I think that the standards are coming. We're not trying to do it without a widely adopted standards. So Current OS is taking the lead and with their design reference guide that I think is really helping. But as we look at like UL 3001D, I mean, really a lot of what's going into that committee is what's coming out of Current OS. So I think it's just a matter of time, and the time is now. But the time is also now to close up our session. So before we depart, I want to put a plug into our for our upcoming webinar. We'll have Siemens guiding the discussion around DC distribution architecture. And we'll also have Harry Stokeman on the call, which Harry is one of the biggest DC experts that I've had the pleasure to meet, and really fascinating conversation where we're going to dive deep into the collaboration that we've been participating with several market players, OCP, and really talking about how that space is going to evolve. For those of you that are also looking for different ways to get involved, Current OS membership is always open, and we have an event coming up in January. If you are not a member, feel free to pursue that membership. And in January, we'll have our next General Assembly in Portugal. So beautiful location for that collaboration. And again, I'd like to thank you all, thank our guests for the wonderful conversation, and thank you guys for attending. And remember, if you want to go back or share with a colleague, we'll always have this available for you on our YouTube channel. So thank you very much, everybody, and have a wonderful day.
Thank you.